Today we're going to talk about slope. I've mentioned this before. We have discussed rate of change, we've discussed constant rate of change, and now we're going to discuss slope. Ultimately, they all refer to the same thing. So the slope describes the steepness of a line, just like a rate of change, and it is the ratio of the rise to the run. We've stated this previously as well. That's the vertical change, the rise, to the run, the horizontal change. And again, it just describes the steepness of a line. The formula is the same if you have 2 points. You can calculate the slope by finding the difference between the vertical change and comparing that to the difference of the horizontal change. So the slope equals rate of change. It's rise to run. It is the vertical change to the horizontal change, and it is also y2 minus y1 over x2 minus x1. The slope is the same for any 2 points on a line. We do have a couple of special cases. So let me just go ahead and draw a couple of axes here. And these can be rough graphs. Let me try that one again. So in general, if you have your x and y axes, I have one more that I'll draw in just a moment. I'll put that underneath. You might have a line that looks something like this. Okay, that represents a positive slope because it is going up and to the right. You might have something like this that represents a negative slope. And here are the special cases. This is the first one. Let's say you have a horizontal line. Now in this case, let's say this is 1, 2, 3, 4, 5, 6, y equals 6. Okay. This would be the equation for that horizontal line. It is a function because it passes the vertical line test. But if you were to calculate its slope, something happens. So let's pick any 2 points off of this line. Let's say this is the point 2, 6. And over here we have the point 3, 4, 5, 6, 7, 8, 6. So we can find the slope as we do with anything else. Take our 2 points, subtract the y values in the numerator, and subtract the x values in the denominator. So we have 6 minus 6 over, and it doesn't matter whether you do 8 minus 2 or 2 minus 8. So if we did 8 minus 2, you'd get 0 over 6. If you did it the other way, depending on which you labeled the first point and which you labeled the second point, you might get this, which would be 0 over negative 6. Now, you don't usually have fractions that look like this or ratios that look like this because we do need to simplify. 0 divided by anything equals 0. So whether we have 0 divided by 6 or 0 divided by negative 6, they both equal 0. And in this case, that would be the slope. The slope of a horizontal line, any horizontal line, is 0. So what's the other special case? Well, maybe you can guess. That other special case is when you have a vertical line. So this was the one I couldn't fit up there. So let's say we have something like this. Okay, we have a vertical line. Is this a function? No, it's not a function. In this case, we would have an equation of the form x equaling 2, and it is not a function. It is a line, it is linear. It just does not pass the vertical line test because a vertical line would hit every single point on this line. We could do the same thing we did before in terms of finding the slope. So if you have a vertical line, you can go ahead and choose any 2 points on the vertical line. Let's say we have this point 2 comma 1 2 3, so 2 comma 3 and 2 comma 4, and go ahead, subtract your y values and then subtract your x values. So I'm going to do 4 minus 3 over 2 minus 2, but again, if you had your points organized a different way, you might have done 3 minus 4 over 2 minus 2. And what you find in each of these cases is that you get a 0 in the denominator. And within our number system, it is impossible to divide by 0. You cannot do it. It is undefined. So it doesn't equal 0. It is undefined. It equals no number. Okay, we do not define a slope. There is no slope for for vertical lines. So those are the two special cases. Let me just scroll back up so you can see them again. We have our horizontal line, which has a slope of 0, and it is a function. And then we have our vertical line, which is not a function and has an undefined slope. Now we're just going to do some practice where you find the slope of different lines that pass through given points. So let me task you to do that. Find the slope. Here, the only difference between slope and rate of change, typically with rate of change, we have a graph that's labeled, and we use words to help us describe the rate of change. With slope, you might not be given a specific situation. You might just be given a graph with some points, and so you come up with a slope, and it will be maybe 1/3 or -2/5 or 0 without any labels. So that's typically, no labels. Let's say we have a line that goes through the points 2 comma 2 and 5 comma 3. I could draw this out, but instead we can use the formula to figure out the slope. So that's the first one. Let me give you another one. -2 comma 1 and 0 comma 3. So that's another line. And yet another line, -1 comma 1 and 3 comma 1. And here is the last line we are going to calculate the slope of. It happens to pass through the points -5 6 and -5 comma 2. Please hit pause, use the formula, and come up with a slope for the lines that pass through these given points. Hit unpause when you're ready to see the solutions. Okay. So here, again, depending on which you labeled your first and second point, you might have something slightly different, but I'm just going to do 3 minus 2 and then 5 minus 2. That gives me 1/3. That is already simplified. I am done. Please note that you do not have to have unit rates. Do not have to have unit rates. Let's calculate the slope here. I'll do -3 minus 1 over 0 minus -2. Be extremely careful with your minus signs and your negative signs. You can write it as plus negative if you'd like, if that will help you to do the math. You will get -4 over 2. This does simplify to -2 over 1 or just -2. Either answer would be acceptable to me, as long as you recognize that you do have a vertical change of 2 and a horizontal change of 1, of -2, and a horizontal change of 1. Here, when we calculate the slope, we get 1 minus 1 over 3 minus -1. So that gives me 0 over 4. You cannot leave it this way. You must recognize that you have a slope of 0, and it wouldn't hurt to go, oh yeah, this is a horizontal line, because I will be asking you things like that. Let's check this one out. 2 minus 6 over -5 minus -5. That gives you -4 over 0. Again, you cannot leave it like this. You have to recognize that when 0 is in the denominator, the slope is undefined, and this represents a vertical line. What I'd like you to do now is to get out page 38, that handout that you have, and I would like you to go ahead and read through and complete numbers 19 and 20. Remember, the idea of a slope is that it is rise over run. That will help you to interpret the words, and you do not want to make your slope into a mixed number because, again, it's a ratio. You're comparing one type of quantity to another. Hit pause, and when you're ready to see the solutions, hit unpause. Okay, for number 19, we have 4/5, and for number 20, we have negative 7/4. It's negative because it says what is the slope from the upper left corner to the lower right corner. Okay, I will see you in class tomorrow. Thanks.